Well, hello, how are you? So, starting Unit 6, which is arc lengths and arc measure notes. So, I'm going to just go through this, give us an idea of what our lesson is on today. Um, all right, so arc length and arc measures. So, when we're talking about arc lengths and arc measures, we're talking about circles and we're talking about parts of the circle. So, just to give you an idea of what part we're talking about, if I was going to draw a circle here, a perfect circle, just freehand circle. Okay, not a freehand circle. A freehand circle here. Um, let's just make sure that we're aware of a couple things about this circle. So the first part I want you to be aware of is this idea. We're talking about arc length and arc measure. So the first thing I want to be, or first thing I hope you're familiar, you familiarize yourself with is this idea of arc measure. So I just a little arc here. I want you to think for a second. Um, Between these 2 points, I'll call it AB. If I was going to measure not the distance, but actually the opening between those 2 points, I would call that an arc measure. Measure of A, B, and notice I put this little arc on top of it. So that's what I'm doing. And we measure arc measure by measuring the central angle. And the central angle is when we find the center of the circle, I'll call it point C. And when you connect those two endpoints of the arc, with that center, so we create this angle right here, this angle opening right here, and this is called a central angle. So this is the key part to our circle. The central angle is just an angle with the vertex at the center of a circle. Center of a circle. In this case, you can see it's point C. This point C is the center of the circle. It's also the vertex of the angle. And one thing I want you to realize is that that central angle measure and the arc measure are the same. They're congruent. So if this central angle measure looks to be a little more 90, let's call it 95. If this was 95 degrees, if this central angle, if the measure of angle ACB was 95 degrees, then we would say that arc measure would have the same measure. It is also 95 degrees. So know that when I have that angle measure, it's the same as that arc measure. Okay, very good, excellent. Moving on, we'll talk about what is an arc. I kind of just told you that, but it's really an unbroken part of a circle. An unbroken part of a circle. Now you can see that I label it, I use the endpoints A, B, and I put that little arc over just like I did over here. You have really two different arcs, because if I was talking about AB, couldn't I be talking about if I used, couldn't I be talking about this arc? I mean, why not the bigger one instead of the smaller one, like this side from there to there? Why didn't I pick the bigger one? And that's because when we deal with arcs, we almost always deal with the smaller of the two arcs. But I do want you to be aware of the two different arcs. The smaller ones are called the minor arcs. And this is the one that we're going to be dealing with it almost all the time. And it's any arc that's less than 180 degrees. Any arc Gal, you're not bothering me, by the way, even though I'm filming. And now you're famous because you're going to be online, YouTube now. Okay, wow. Okay, it's any arc that is less than 180 degrees. So we can make the assumption that a major arc is going to be any arc that's greater than 180 degrees. Oh my. That's greater, G-R-E-A-T, greater than 180 degrees. Now, I will make another note here that when we label a major arc, we will always use 3 letters. That's the way we'll distinguish between major and minor arcs. A major arc will always have 3 letters. Sometimes minor arcs will have 3 letters too, but major arcs will always have at least 3 letters. So if I was looking at this purple arc, I would say the measure of A, and then we do it like we draw it, A to D to B. Now you see that if I was, and then I put that little arc on top of it, you can see that if I started at A, I'd come through D and then I'd end at B. So I have my beginning at A and my end at B, and that's where I would do it. And I need to have that 3rd letter in there if I'm going to have that major arc labeled. And then, of course, the thing we haven't yet talked about is what happens if I'm talking about an arc that is 180 degrees. Well, that's called a semicircle. And these are all arcs equal to 180 degrees. And we also are going to use 3 letters to label that because we want to know which direction we're going. Are we going the top half or the bottom half? So we will need to have 3 letters also when we talk about a semicircle. Okay, so let's talk about the 2 different things. So we know that this the arc measure is the same thing as the central angle. I already talked about that. I want you to put a little note here, just a little highlight here. That's we already mentioned. I mentioned that up there, but it's a key piece, and we're going to need that information to figure out arc length. Now, the difference between arc measure and arc length is that arc measure is actually the distance. So, like in inches or feet or miles or centimeters or whatever. So, if I was talking about this arc length, I'm actually talking the distance it is from A to B traveling along that arc. So it's going to be different than arc measure, which is just the opening or the angle that's opening, okay? So arc length is, it's the distance along the arc. Okay, so arc length is the distance along the arc. All right, so I got a couple things. There's let's start with this very basic example. You're going to have no problems with this because I'm going to show you how to do it. And if you don't know how to do it, I'll show you how to do it. It's not a big deal. But let's suppose I had a central angle and it measured 80 degrees. So I come here to my center, come over to here, and I tell you that this angle ACB, the measure of angle ACB equals 80 degrees. Can you tell me the measure of arc AB? If I tell the measure of AB, well, if I know that this is 80 degrees, what is the arc measure? It's the same. It's the same. It's the same. Okay, so that's it. It's that easy. Sometimes people in math say, "Well, I thought it was supposed to be hard." This is not hard. This is plug that sucker in. If it's 80, then the arc measure is the same. It's the same 80 degrees. That's simple. It's knowing that relationship that's important. So we really want to know what that relationship is, and the relationship is the same. Central angle, arc measure, the same thing. Should I say it one more time? Will I make more emphasis on it? Arc measure, same thing. Central angle, same thing. Arc measure. Okay, can't do it anymore. Okay, so let's talk about sector of a circle. Now this is a piece of pizza. So if I was drawing another circle, man, I'm so glad I have this feature that allows me to just click buttons. But if I'm talking about a sector of a circle, again, I'm going to that center. I'm actually talking about that slice of pizza, how much area is in that slice of pizza. And there's a formula for it. So here's the formula for the sector area. So the sector, it's first let me give you a definition. It's just a region. It's a region bounded by 2 radii. That's just plural for radius. That's this, I'll do it in green. That's this length right here. This is called my radius, my R. So I've got 2 R's here. So notice that, and by the way, that R value is going to be the same on both sides of that. But Anyway, it's the area bounded by two radii. And think of it as a piece of pizza. I don't need you to memorize this formula. I need you to know that we're talking about a slice of pizza here. So once we know that we're talking about a slice of pizza, we want to know how much area is in that slice of pizza. And so here's the formula. The area of a sector of a circle equals pi r squared. That's the area of a circle, right? Pi r squared. And then we multiply it by the arc measure divided by 360. It will always be divided by 360. So once we get that central angle, we divide that by 360, and we multiply that by by pi r squared. Yeah, straightforward. That's how it works. Let's find a sector of a circle. I'll move on to page number 2. Stop this if you need to write these down or whatever. Okay, so let's go to example 2. So I'm going to go here. I got my circle. I've got a sector. I'll tell you that this angle is 50 degrees. I'll tell you that the radius is 360 feet. Now I'm going to change that. I'm going to say it's 36 feet. And remember last time I was talking about, but feet is marked with just one dash. So that's a feet. Okay, so my radius is 36 feet. My central angle is 50. So let's plug it into that formula. A reminder, the area equals pi r squared times arc measure divided by 360. I kind of put some shortcuts, but you've got it written down already. So now let's just plug in what we know. Well, pi is 3.14. R in this case is this value, 36 squared, times that arc measure. Well, this central angle is 50, so this arc measure is also 50 divided by 360. Now, if I plug this into a calculator, here I go, I'm reaching in, pulling out a calculator because I don't know this answer without doing it. All right, so I'm going to say 3.14 times 36 squared times 50 divided by 360. Now, notice that when I did this, I multiplied this by 50 and then divided everything by 360. That'll give you the correct answer. So when I did that, I got 565.2. And now I need to make sure that I'm telling people that these are tile. This is pizza. So it's feet squared. This is square feet. Good. All right, so the next concept here, another formula. The next concept here is arc length. Now, we're not talking about arc measure, which is the same as the central angle. We're now talking about arc length. We're talking about how far it is between those endpoints, distance. Could be inches, miles, whatever, but we're going to be looking at arc length. So here is the formula. I'm just going to give you the formula. And again, the key piece is knowing that there's a relationship. There is a way to figure out arc length. Come back to your notes when you need it. But here is the formula of arc length. Arc length divided by the circumference, which is 2 pi r. That's going to equal again, we're going to go with this arc measure, which is the same thing as a central angle. And divide that by 360. Wait a minute, didn't we just do that? Yes, we did. And it's still part of this one too, so it's really important. Okay, so let's try this formula then. I'm going to be kind of lazy and not write the whole formula out each time. I'll probably abbreviate some of them, but you know where it comes from. So go back and look at this if you need it. Some people say lazy. I say just efficient. Isn't efficient a better word than lazy? Don't you think? Efficiency better than lazy? Thank you, Gal. Appreciate you seeing this. Okay, so if I had 2 points on this arc, if I had point, No, that's not what I want. I want this. If I had 2 points, point C and point D, and I told you that the arc length, or excuse me, the arc measure is 90 degrees. And I told you that I had a radius here, and I'm doing this on purpose. I'm not attaching them because we don't need them to be attached. And I told you that this radius was 10. Well, we can plug this into my formula, and let's do that. So first thing I want you to understand is arc length is what we're looking for. They said find the arc length. Well, when we're looking for something in math, we put in x. And then I notice what I'm doing is I'm just taking this formula right here. I'm just going to kind of highlight it so you can see what I'm doing. I'm taking this formula right here, and I'm just going to plug in everything I know from that formula, and it's going to help me figure out. But I put in arc length. I don't know that, so I put in x. 2 times pi, that's what 3.14, times my radius, well, I have that value right here, so it's times 10, equals that arc measure. Now, that arc measure in this case is given as 90 divided by 360. Okay, now before we move on, this is one of those problems where students who don't have much confidence in math think that, oh, I don't know how to do this problem. It looks too complicated. But I'm going to remind you, I'm going to say actually 2 words, and you're going to be like, oh, of course, I know what I'm supposed to do. The 2 words I'm going to say are cross multiply. And once I say cross multiply, people are like, oh, yeah, I totally know what I'm supposed to do. You're supposed to cross multiply. You're supposed to take these 2 things and multiply them together and then divide by this. So this is actually a calculator problem. I'm going to pull my calculator out again. Recognize me, Siri? Okay, good. You recognize me. So then all I have to do now is I need to multiply 2 times pi times 10, multiply that by 90, and divide that by 360. Wow, it gave me an answer of 15.7. And because I haven't given you the label, I should have probably said what this 10 was. Let's call it 10 centimeters. So when I get this answer of 15.7, it's actually 15.7 centimeters. Because we're talking about this outside edge here, because we're talking about not the distance from, or excuse me, the distance between here and here, because we're talking about that distance, we need to label it as a distance. And centimeters is a distance. So we label it as centimeters. Okay, that concludes our notes today. Good luck, and I'll talk to you soon.